Session 5.2, node networking. All right, Sock.io. This is where things get very interesting. We're talking about node.js. You can do a lot of fun stuff with this, and it's one of my favorites. So we're going to talk about that a little bit. Let's go forward. We're going to talk about node networking and WebSockets, and we're going to talk about what a WebSocket is, because we can't talk about Socket.io if we don't know what a WebSocket is. There's no point. We need to know. And we're going to continue on with why Node is so great for networking. We already covered the event loop and its asynchronous nature, and this is a very good application of it. So Node for networking. Here's the power of Node. Now we're getting past little simple event emitters, and we're going to see how we can really use them to build something cool. So we talked about the HTTP module, right? Handling when Node is a web server and handling HTTP requests, but there is also another module that is called the net module. And again, it creates a channel between servers and client. We call it a stream. And it provides an asynchronous network wrapper around that with all those events and those handlers and those kind of things. Again, this is a base level protocol. We're going to talk about what kind of protocol it is, TCP, but we're not dealing with those web page requests anymore. We're dealing it at a lower level, right? So the net server class is used to create a TCP or local server. Again, we're talking about a server, but now we're talking about a TCP server, right? A local server without all of the heavy header transmission that comes along with the HTTP, which is Hypertext Transfer Protocol. We are at the lower level, right? That connection that happens before all of that happens. There's also another class called the net socket. So it's an abstraction of TCP or local socket. That's where we're talking about WebSockets. So when we're looking at the code here, again, I went on and on about how great it was. We could create a web server with the HTTP module. In the same vein, we walk up to it and we say, I'm going to use the required net module that's built in. I'm going to set it to net, just my variable, and then it has the same method. It creates the same kind of object, create server, with a callback function, right? In one line, we are creating a server. That's powerful, right? As we know, behind the scenes, because Node.js, JavaScript is a syntactic sugar, underneath the underlying runtime is that all that C and C++ code. Because when you say net create server, when it transpiles down, it's going to go through all that internal logic in C, and it's going to open up a server connection, something that is going to be fired up, ready to handle ports and all that stuff. And it's going to return to you server connected, and then we trigger an event. We trigger an event here when the connection is ended. Then we fire a callback that says server is disconnected, and then we can write some things and pipe it. And then we also have the server listening on a certain port, because now we're not really worrying about localhost anymore like we were with the web server. Now we just have listening on that port, and when that port when it fires up on the port, it says the callback says the server is bound. So HTTP module versus the net module. We use HTTP create server to set up a server that handles the HTTP protocol, which is again transmitted over top of the TCP. Right, the TCP has to create the connection before the web page request can come and go. Otherwise, we use this net.create server that goes and just all it does is simply understand TCP connections, that they've happened and that data is being transmitted. It doesn't know anything about the web requests, right? This is the layer, the protocol underneath all of that. So if you're writing a web server, use HTTP module. If you are using, so you would use that anytime you're using the web, HTTP, right? That's the protocol. Otherwise, if you're dealing with just TCP connections or other kind of networking, you use the net module. There's other protocols like UDP and things like that. You would not use the HTTP module for those. But when we're talking about HTTP, we might as well talk about what it is, because we've already talked about it. So now that we mention it, let's give a little definition on it. So HTTP stands for Hypertext Transfer Protocol. It's the basis for all data communication on the internet. As I mentioned before, I had a little historical thing there that CERN, members of CERN, right, actually created this in 1989. just for trivia for yourself. Um, so the data communication always starts with a request from a client. So you could say maybe that's a browser or a mobile device, and it ends up with a response from the web server, right? You have a caller, and you have a listener that returns something to you. So this communication usually takes over that underlying protocol layer, which is the TCP/IP connection. But here's a little diagram. You see a request comes in the small text server. You see the request has a little bit of headers. We're not talking about that yet, but when we're talking about headers, we're getting more into like express and all of that stuff, right? The response comes back, and we're talking about the data and the headers. Again, inside of the header, there's a bunch of status codes, okay, and whatnot. So there's a bunch of stuff in there when we're talking about when we look at those ACP requests with Express, we're going to dig into those a little bit. But we're dealing with protocols right now, and we're going to talk about TCP/IP, so we don't need to dig into that too much. So, but however, I corrected myself. I didn't even know it was on the next slide. We're looking at this right now. Okay, why not? Why not? Uh, hidden cost ACP. Why am I? There's no better time than I guess to talk about it right now. So on the left side, we have an example of the headers. I stand corrected here. Make myself laugh. Um, it has status 200 OK, and it has a bunch of information on there. And this is a hidden cost because there's a lot there. So when we're doing the TCP connection and when we're establishing new connections, right, it's basically on that level. The HTTP sends across this header on every single request and response. So it's always going and always present. It can vary in size and quantity, right? It can be, sometimes you might get into a very big problem when you might have a tiny little message, like maybe you need to just get the status on something, whether you're logged in or not, and you're pushing around these big headers back and forth, right? And that can be a problem. That again is a hidden cost of these requests. If you're familiar with your Chrome tools and using your network tab and your Chrome developer tools, you'll see the responses going back, and you can dig into the headers and see exactly what we're talking about. Just for very small data, it's a high cost. So this is a problem because I've done this before. So there was no mechanism before for the server to independently send or push data to the client without the client making requests. So that's true, right? You and I had to code this before, right? In the mechanism, there was no way before that actually could independently send out and the client would be listening, right? Um, you would have to do such things, and I've coded this before, where you would have to do something called polling. So polling, would overcome this problem where the client polls repeatedly for new information. And I've done this before. I remember I did an application where I was, what was I doing? Okay, it was a very cool app. It was for telecom. It was like a GPS tracking. Each each guy in the truck had some transmitter that he'd carry around with him. It had some networking, other types of functionality to it where you connect it to the network, and it had a big antenna in it. It was constantly sending packets back to the server, like GPS coordinates. And I had on the other end, I had a client UI that was constantly polling that server to check the status if there's any new packets and trying to get information. But I didn't have a way of broadcasting from the server, so I had to have, the desktop app that some technician was using to constantly, every 30 seconds, send a request, come back, send a request, come back, send a request, come back. And if there was data there or not, it would just basically constantly be triggering this thing, right? So on the left there, that's my long-winded example, but on the left there's polling, and what we're saying is the client makes a request, empty response. Request every 30 seconds, empty response, until finally new data comes in, and it's not real time. So that's the problem, is it's not real time. You fake it till you make it, but it's not real time. It's useless calls. So you might have this thing polling for an hour without any data, but it's constantly polling. Versus long polling, where you have, it's not real time, but you have one big request. You just say, I'm waiting. And then when the server comes back, it finally returns. So long polling, the server waits until it has data to respond. Each request and response creates and closes connection, but the client has to wait for a very long time until the data is served. So that's what polling is. So it's very inefficient. It fakes it. It's not real time. So when we're talking about WebSockets now, WebSockets, very cool thing. And they let you do a lot of very cool stuff. And it allows us to do real-time applications. And the real-time applications, in my experience, they seem to be the most fun. I have a lot of fun with that stuff. So we have something called WebSockets. And basically a WebSocket protocol allows for that two-way communication across a channel, right? And we're going to call it a single TCP socket with a remote host. And the power of this is it's bidirectional. So the client and server can send messages at any time. Once you establish the connection, the channel, that channel is open and you get real time right across that channel. Full duplex means that they both get updates at the same time. And I'll show you a little example of this when we look at socket. Oh, it's quite cool. And you'll see the difference of, you would notice a difference of an application using polling versus one that uses sockets. It's like night and day because it truly is real time. And you've had experience using many applications that you don't already know that will use WebSockets, and I'll talk about those in a little bit other slides to come. Single long running connection can be established, so you can have that connection for a long time. It's a very effective use of bandwidth and CPU because not constantly tying up resources to respond, request, right? Headers coming back and forth, all this computation. Maybe you have a watcher, like all that stuff. We don't need that. So here's what it looks like. It looks like a handshake. So a client initiates the connection and the server responds, it accepts an upgrade. Again, there is some type of header going back and forth, but basically it comes in and it establishes a handshake. The connection is open. So there's an opening and a close, but in between that, there's a message that goes back and forth through that channel that's persistent. It can constantly be sending messages over time until one side loses the connection and the channel closes. So once the WebSocket's established, both sides notify each other that they're open. We're ready for business, right? Either side can send messages at the same time, and then either side can close the connection, which is great. Again, we'll talk about more about that, but you have multiple connections on the same channel, which makes it great for a lot of things we're going to talk about. So again, there is some kind of protocol here that goes back and forth. There's header, but it's a lot smaller if you notice than that HTTP. It's very compact. So the server sends a request. It has a bunch of header information here. It has a request that it wants to upgrade to a WebSocket connection. This is for your knowledge. If you were to look at some of the networking tools like Fiddler or Wireshark or something like that, you could actually look at some of this protocols going back and forth. So WebSocket handshake headers right there. So it has a key version protocol. The server knows what to do with those. The server will respond, basically say, I accepted the upgrade, and now we have a handshake, now we have a connection, now we have a channel. So this is what's happening in behind the scenes. So why would you want to use WebSockets? Like we talked about, real-time application. This is the power because it's there, and I'll show you an example of it. There is presence, right? You have real time, so you can have a whole bunch of great applications. Low latency two-way communication for gaming, right? Counter-Strike, Call of Duty. Hey, I play Space Invaders. I don't know if you guys know what that game is, but that's an old school game. But Space Invaders online against other people, how can you go wrong? If you know Space Invaders, you know you can't really play against another person. But anyhow, Space Invaders. Look it up. Look, Qbert. Qbert's another one. Look that one up. I guarantee you like that one. All right. Collaboration, live wikis and documents, right? When you're using Google Docs, you can start typing and you see the presence that somebody else is working at the same time. That's not using polling. Polling, there'd be a delay and it'd be awful, right? It's using sockets. Dashboard for financial apps. I've done kind of this stuff. When you basically update live data at the same time. Really cool stuff. Tracking, right? Tracking user actions. Presence. Instant messengers, chatting. Anytime you're using one of these chatting applications, you're using WebSockets. You have presence. You can see the person typing. You know they're there. It's a different feeling, right? When you're working with that kind of thing than dealing with a web application that is loading and slow to react, right? This is what we're talking about. So that is real-time application. What HTTP doesn't deliver is real-time. Polling, long polling, stream, hidden iframe, awful. awful solutions if you ever had to work on an iframe, especially. When someone says, I need you to work on my iframe, run. Please run, because it's old school and it's hard to work with. Slow, complex, bulky, that's for sure. Rely on plugins, Flash, Silverlight, Java. Those are old school now, right? But this is what we need to rely on to fake it. So here we go, WebSockets versus HTTP hacks, right? I've done the hacks before and I know why you got to go through the pain to appreciate this stuff. So I've done the polling and I've done the long polling and now I've done the sockets. I can tell you go for WebSockets wherever possible. Look at the latency on that. So low latency, no TCP connection for each HTTP request, low overhead. That's why you would take WebSockets. Low overhead for each message sent. 2 bytes in a WebSocket connection versus all of that, you know, data. I wouldn't say junk, but all of that big, heavy payload in HTTP. Why would you want that if you don't need it? Less traffic, so you don't need to pull. You just open up that channel. You have that two-way communication. You do that handshaking. You know the deal's done. You know you can actually start doing business, right? You don't need to keep checking. You know, are you there? Are you on my side? Right? No, we're there. We're ready. We have this open connection, and we can start doing work. Right? We can start doing the business. Socket.io. This is a great little library. It's so great that I always like to include it in any kind of session I do in any kind of lab work because it basically allows you to do a whole bunch of fun stuff. So what it is Socket.io is a real-time framework, application framework, is a wrapper around WebSockets. So we have this wrapper that gives us a bunch of events between the client and server, publish subscriber kind of thing. And why would we want to use it? Because it's a fallback for older browsers. Like basically this script can be used for browsers and on node.js, but it has compatibility with older browsers, so that's one reason. Native support for all devices, and a very trivial API. So let's just quickly look at Socket.io. If we were to go to the website here, it has a nice little UI, a nice little kind of documentation on it, a lot of resources on starting and getting started. It has set up with Socket.io, a little introduction on the framework, the web framework, how to get set up. You do npm install like you would Express. And basically you set up the web server and you can you're serving a web page because you need a UI to work on this. And once you get that up and running, it tells you how to go about adding the library to the UI and adding the library and building a tiny little chat application. So you can build a nice little chat application with Socket.io, and there's a nice little library and it'll take you through all that. Just know what it is. So the main features about Socket.io is reliability, right? Connections are established even in presence and proxies, firewalls, antivirus software. So it has something called Engine.io, so it deals with that. So it's very reliable. Auto connection support, unless instructed otherwise, a disconnected client will try forever until the server is available again. So it deals with auto connection. You don't need to worry about that. Again, disconnection detection. It has a heartbeat mechanism implemented at the IO Engine IO level. Again, this is internal to it. You don't need to worry about this, but allowing both server and client to know when one another is not responding anymore. That's pretty big. Again, you don't need to worry about that. It all handles it. When you're using the trivial API, you're like, wow, this is so easy. Again, it's what's happening behind the scenes for you. The heavy lifting is done for you. Binary support deals with serialization, right? Multiplexing support, which is awesome because you can create separate communication changes, namespaces that will share the same underlying connection. So basically what that means is you can have the same connection and you have multiple users connected on the channel and you can go off and do namespaces. What namespaces is you can do separate private chats. You can basically do these kind of things like that you can actually pull people in and do a private chat and protect it against a general kind of chat, right? Room support, so you can create arbitrary channels that sockets can join and leave. You can then broadcast to any given room, reaching every socket that joined, like again, a private chat. So there's a lot of features here and it's very fast and you can really whip up I won't say whip up, you can you can develop a chat application with this library very quickly and it's very powerful. Try doing that with frameworks of the past like .NET, maybe 5 or 10 years ago, and we could compare the code, and you'll see what type of complexity you would be getting into here. Um, you'd have to be using some type of, if you weren't using WebSockets, you'd have to go through a lot of fake it till you make it kind of code, right? So let's see. Here's an example here of a simple API connection. So you have an IO, which is socket IO. It creates, again, they all inherit from event emitter. You register your listener, so on connection. So now I'm registering that when there's a connection established, the function is going to have a callback function that has that socket that creates a connection, and then I'm going to emit an event to the socket that a request has been made. I'm going to emit to all events on the connected socket that broadcasts. I'm going to emit that, and then I'm going to register a listener on reply to listen to the event. So when you are using this library, again, we'll talk about, there's a difference between IO and socket. IO is the channel, and the socket is the connection coming in. So basically, when you're talking about IO, you're talking about all connected sockets on the channel. And then when you have the socket, that's the new one that has joined, the new person that has joined on the channel. All right, so socket IO uses. Again, if we're talking about real life experiences, real life applications, notifications on Facebook and Twitter, when you get those notifications pop up in real time, that nice messaging, that stuff that makes you feel like, the site is alive, that's using socket IO and using sockets, right? You can't really um, create that kind of presence with web. I mean, you can fake it, again, like I said, and I've done it, and it does kind of work. But to get that instant messaging going, that feeling that somebody's there and you're chatting, that's what you need this kind of protocol for. Dashboards, we talked about that, real-time analytics, group connections, multiplayer games, the online gambling, right? Don't gamble, but if you have to do it online, and don't use your own money. Try to use fake money, virtual money if you can. Google Docs, and then products, right? Office, Yammer, Trello, and like Slack. When you're on Slack, it's a great tool when you're constantly chatting and you see people writing and typing. It's very interactive. So quick setup here. We're just going to show what you need to do. We can look at the documentation, but you would walk up and you would use npm install. We're again downloading it from the node npm modules registry, socket.io client. And here it is. It's very simple. On the right side, you have a web page, and you basically use the web version of the script, socket.io.js, and you open up a connection on the client side. On the chat window, you open up the connection on localhost, and then you set up a listener on it and a callback function, and then you emit. On the server side, you require it. You require I/O to require socket I/O on the server. Now the API is the same on both client and server. You just wire it up differently, right? Here we go through the server's listening on that port. Again, a TCP port. Sorry, it may kick off it may handle a web request. So now we're giving this index.html, which is on the right. So now the client has a UI, and then on the TCP protocol layer, that socket can be opened up, and on the server it says it's listening for the connection. When this connection is open, it emits back news, hello world. If you look on the right side, it has a listener news, right? I'll use my pointer here. Why not? I have a pointer. I might as well use it, right? Here we have this connection opening, and we emit news here, right? And over on this side, we have a listener for news. So when this listener gets triggered, it'll kick off this callback. It'll say it's going to console log the data, which happens to be hello world, and then it's going to emit back. My other event is my data. So it's going to emit this event, my other data, which on the server side now, across that channel, there's a listener for my other event, and it's going to have a callback that logs the data. So we have this interaction going back and forth already from the server in just a little bit of a couple lines of code. So what socket? Let me get rid of this pointer because it's like a laser and it's going to give somebody some problems. So let me turn it off. All right. What Socket.io is not. So Socket.io is not a WebSocket implementation. When you're talking about Socket.io, you're not talking about WebSockets. There's a whole other libraries for that. This is a wrapper over top of that to protect that underlying socket, and you're just using the API. So it adds metadata to each packet, which is really nice. There's a packet type, there's a namespace, and there's an ID. And the ID is an acknowledgement ID, which is really great because you know when a message is acknowledged or when it's needed. Basically, it wraps that you don't normally get from the WebSocket. So a thing to note, a WebSocket client will not be able to successfully connect to Socket.io server, and a Socket.io client will not be able to connect to a WebSocket server, which makes sense, right? We have a wrapper object, cannot talk to the original object, right? They both need to be of the same type. So the API is very, very basic. Here's the server API. On the server, you have IO dot on connection. It could be any named event, and you have a callback with the socket that says a new connected client. That's the server, right? The socket itself has a couple things on it. It has like an event emitter, it has an on, it has an emit, it has a broadcast emit. I don't really use the broadcast emit too much, but you will use it if you want to send to all clients. So if you're dealing with a socket, attach a listener for a given event, emit send the event. So this is a little different than event emitters. Socket.broadcast.emit sends the event to all clients, to everyone connected. Client API is even smaller. It has two little tiny listeners. It has .on, attach a new listener for the given event with a callback, and it has an event, emit, so you can send the event to the server, and that's it. That's all you got. Socket on connection and emit. Very simple, very simple. So if we were to build a chat application, we would have for a second here. Let me just take a break here and take a look at Socket.io. I just wanted to show you an example while I'm talking because this is kind of relevant, and you know what? I just want to take a break from the slides, to be honest. So here we got two windows here that show Socket.io and the whiteboard, right? I mean, there is a chat function, but I don't want to go in there in case somebody starts arguing with me while I'm doing this presentation. But if we had, I have two instances here, and all right, so we can pretend that we're two separate clients connected across the same channel. So if I pick blue on this side, and you'll notice when I start drawing on the left, you're going to see it automatically on the right, right? Look at that. So we have a client here going like this. So now I'm on this screen and I'm doing right. And you can see how instant in real time that is, right? There is no lag, there is no delay, right? We are actually reflecting the changes, right? In real time, right? So you can see the power of, you can, I don't know, maybe someone's watching, they don't know what I'm talking about. I love node, whatever. Anyhow, I wanted to show how responsive and reliable that is. That's why I wanted to show that before I finish up this slide presentation. Back to the slides, but you know what? 3 more slides, I promise. Only 3 more, but after this I'll actually show you a really cool chat application that you can use with Socket.io and some of the other technologies in the MERN stack, which is React, MongoDB, Express, and of course Node using Socket.io. I'll show you a nice little chat in 3 slides, so just stay with me. So building a chat application. A client side. So we can have a client side, which could be EGS template view. You might not know what that is, but out of the box we have that. It could be React, it could be whatever you want. It could be Angular or HTML, CSS, and jQuery. Whatever framework you want, you can use. You just use the Socket.io JavaScript library embedded. That's your client side. And then you have the server side. So when we're talking about the MERN stack, we're talking about node.js, which is the web server, Express API, which is the API layer, and then of course we have Socket.io. And as we're requesting a page to the server, we respond back with the interface, and then we open up that channel, and off we go. Chat server. So I'm just showing you how to make a sample server just using node.js. We haven't talked about template engines, and we will. But this shows you out of the box. You could build one quickly without having to worry about a UI or a React or anything like that. So there's a concept of template engines where it's you basically run an install on server side, so the server renders the file. It's more of a server side um, generated UI instead of having like a client side UI like React or something like that. We'll talk about the differences in a later session, but for now we're just talking about node.js. So we could, and bear with me here if we haven't gone over this or you don't follow this. It's basically showing how you could get it up and going quickly from the server side. So we require the Express library, and then we basically set up the template engine. The template engine will handle the request for the page to the HTTP request, handle it to the UI. We set up some middleware. Now we get a route. So we haven't talked about that, and we'll talk about that when we talk about Express. Basically, a route handles the routing of the URL, and then in this case, the base route, we return the index page, and then we set up a port and we listen. Right? We haven't really set IO up on the chat server, but if we were to do that, this is what it would look like. We use the IO object here that gives us access to the whole socket IO library. The IO object is now listening for each connection. So this is on the right side what we would have to do inside of the server. So we set up IO, we grab the socket IO library, we register an event that we're listening on every connection. When we get a connection, we just say new users connected and we log it. And then after that, we do a bunch of other logic. And that's all we need to do. So with the two here, we basically got a little bit of a user interface, whatever the index.html looks like. But on the server side, we're ready to go. We launched a server, we gave it the client a UI, and now we're listening for any connection on the socket. What the client looks like is this, and this is how you set up a client in a little bit more detail. You add the script reference in that template view, which is EJS, and we add it at the top. When a client will load the file, it automatically connects to a new socket because inside of our client side, and this is using jQuery. Again, if you don't know it, it's okay. I'm just showing this example to give you a context of what you could do. So with jQuery, you can actually do this $sign function, which will detect when the page is loaded or ready, and it's going to make a connection, and it's going to emit a hello world. Just on page load, it's going to fire a hello world. On the server side is listening for that connection. On this side here, let me use my pointer again. Why not? Because I have lasers. All right, so I'm talking about the client side here. This is jQuery, so it says when it's ready, wire up this connection, and then emit on the socket hello with this message, hello world. On the server side, again, we are listening for a connection in the socket, so it'll log the console new socket connected. And then on hello, which is triggered from over here, it's going to catch hello, and it's going to get the data, which is passed right here. This is the data package message hello world. It's going to call back, do a callback function, and all it's going to do is get that data and console log it. And that's what that does. And again, you're easily set up with this client-side, server-side connection with Socket.io and very little code. Last slide. I'm pretty sure this is the last slide. All right. So what makes this really powerful is that multiple sockets can connect at the same time. So when you have multiple sockets, you can have a chat with multiple people, which is great. Or you can do gaming. Or you can create your own game that has multiplayer. So each new client represents a new socket connection, and we can define a socket to a namespace or to a room, right? We can basically give them all a namespace, general chat, or we can have different rooms. You can have private rooms and things like that. So it's just a way of segregating the communication. So again, we are going over this again. I'll get my pointer out, why not? Send a message to all sockets connected using sockets emitted. So IO is to everybody, socket emit, hi everyone, and basically the short form is io.emit. So that's to everybody. You can call join to subscribe the socket to a given channel or room. So if you want to segregate the communication to rooms as you would as a normal chat application, you have socket.join and then you have a room. Send a message to any given channel or room, you do IO to the room name and emit the event to it. So basically that's a way that you can send to the different rooms. And basically, if you have a private chat, only send to those members instead of the general chat. Now I'm done talking with the slides. If you've made it this far, I commend you, to be honest, because I've done a lot of talking. So I just want to show one more example, a little cool application. I'll just quickly demo it. I won't get into code, just show you what this can do. Let me give myself time to get set up. So with the power of technology, I will. So this is a really good chat application I came across. It's written in React and using the merge stack, and we don't necessarily need to go into all the code, but basically it's a nice interface. It can just show you how to utilize something like Socket.io. So it has a very nice UI. So I'm gonna pick Rick. By the way, I only watched 2 seasons of. I think I only watched. I think 2 full seasons. You know, the farmhouse thing with that farmer guy. You know what? That just killed me. It took the life out of me. And then they got stuck inside of that prison. I know it gets better, but you know that farmer guy, what's his name, Herschel or whatever. That guy. You know what? When they were stuck in the barn, I don't know what happened. It just sucked the life out of me. First season was really good, by the way, but that I don't know. I don't know what happened to that farmer guy. I hope he became a zombie or something like that. To be honest. All right, so I'm gonna go to whatever. I'll pick Sanctuary. I don't want to pick Sanctuary. That's where the virus happened. Let's see. I'll just pick this one here. It's on fire. So basically, it's saying that Rick has joined this channel, and he can start talking here, right? Hello to the channel. It's pretty responsive. Let me pause this and load up side by side so I'm not wasting time. All right, so I entered as Daryl. So now, you know, as I'm typing here, are you safe? Question mark. So you should notice right away that he's getting it in real time. No, I am not. Right, and basically we can see it going back and forth. Right, so we're getting this information back and forth. If I choose to leave this room, so I'm going to leave this room, on Daryl on the other side should get a message that I've left. So I've left now. So on this side, if I go to another room, another namespace, I will go to Hilltop, and I start sending messages here. Hey Daryl. Right? Daryl doesn't see the messages until he leaves and goes into Hilltop, right? And he enters in here. So now he joined on the right side. You can see he joined, right? And you can see back and forth. I am in quarantine. I am at home by myself. I hope not, but that's where he is. Okay. So there we go. We have 2 really cool chat applications. We have you can basically use Socket.io for this purpose. We talked about Socket.io. We talked about what WebSockets are. We talked about why node.js is really great for networking and why it's great to use and very quick. We talked a little bit, referred back to why it's so asynchronous, and you can build applications very cool like this. Like you can build a Walking Dead app, and what else? You know, why wouldn't you want to do that? So that wraps up this session. We'll talk more about node fundamentals in the next session. Thank you.